Now if this is the neural network, right, you have to tell me how will the connections look like in this fully connected neural network. Okay, fully connected neural network, feed forward neural network, right. You have to give me the total number of parameters in this particular neural network. So how many total parameters in this neural network? This is one of my very favorite questions. You will have a question in midterm on this. Compute the number of parameters in a given neural network. Okay? Generally आज तक ये हमेशा free का question रहा है because I've told it beforehand and more than 90% of the class does it well, but still 10% लोग तो रह ही जाते हैं. Okay, so don't be that in those 10%. I am going to ask a question, I am going to give you a neural network and ask you a question, how many number of parameters in this particular neural network. So how many parameters in this neural network? Throw me a number. 1 second. So we have 16, 18, 19, 15, 19, any number other than this? 19 sahi hai, thank you. Okay? No other numbers? Alright. Now, how will they be connected? So, everybody connected everybody here. Okay? 1, 2, 3. Okay? So, weight matrix. Now, I will not talk in terms of individual weights. I will be talking about in terms of weight matrices. So, here you have W1, here you have W2. Now, so how many parameters in W1? How many parameters in W1? 12. Plus how many in W2? 3. Plus how many bias on first hidden layer? 3. Plus how many on the output layer? 1. And this sums to 19. Okay? Everybody is okay with this? There will be a question in midterm where I will give you a neural network and I will ask you how many total number of parameters in this particular neural network. Okay? Now, एक और बार, then a different example. So, x1, x2, x3, x4, x5, how many parameters in this neural? How many weight matrices do I have? This is for layer 1, this is for layer 2 and this is for layer 3. How many parameters will be here? 20, because everybody here is connected to everybody here. W2, 4 into 3 plus 3 plus how many biases? 4 plus 3 plus 1, जो भी समय. No? One more. This one. How many parameters here? W1, W2, W3. W1 size is 2 cross 2. So 4 plus 4 plus 2 plus 2 plus 2 plus 1. Anybody who still does not know how to compute, raise your hands. Everybody can? Okay. Now, okay, maybe I can do it here on this slide itself. Now tell me one thing, if I have this neural network, what is this? Logistic regression basically, okay. See, I won't talk about linear regression unless I explicitly mention. So this is logistic regression, is a neural network. What special neural network it is? 0 hidden layers and only one neuron in the output layer, okay. So how many parameters here? N into 1, that gives you n, plus 1 is the bias. So this one. Now I want to vectorize this calculation, right. Remember I was writing y hat equal to w1 x1 plus w2 x2 I want to vectorize this. I don't want to do this summation I don't want this equation like this, I want it to be vectorized. How do I do that? So now since we know things like weight matrices, what is my input vector? Input vector, let's say, is this one. This is a n cross 1 vector. See, conventionally when you say a vector, you mean a column vector, okay, unless somebody says x is a row vector. So then again w is a vector. So how will w look like? w1, w2 all the way until wn. This is a size n cross 1. I want to vectorize this calculation. What I basically want is these two guys should get multiplied. So wi should get multiplied with xi. How do I do that? So w transpose x plus b. This gives me this equation, right? Transpose will make this w a row vector. What will be the size of that row vector now? 1 cross n gets multiplied with n cross 1. Final output will be 1 cross 1. And then b is 1 cross 1, it's a scalar, so you can just add. Okay. Now I come back here. I want you to help me vectorize these calculations here. Acha, okay, leave it. I want you to give me equation that computes, write the equation that computes Z12. Z12 is which kind of computation? Linear, okay. So what will it be? Right now I am not looking for vectorized form. This one, if you want to give me an equation, you can give me an equation. Done? Help me write this. So Z21 is W all right, all right. I mean, it does not matter how you nomenclature them. Plus B, which B? B1 2, most likely ये captured नहीं हुआ होगा शायद, this वाला part. Okay. How will W1 look like? देखो, this is something. The dimensions of W1 conventionally, and as you will see in the research papers, is the, so weights sit in between two layers. You could have two dimensions of matrices here, this cross this or this cross this, and they will be the same thing, right? The convention taken is this cross this. So you are in between next layer cross previous layer. So in this case W1's dimension will be 3 cross 4, because number of neurons here are 3, number of neurons here are 4. So it is 3 cross 4. How will you fill in elements in this matrix? This is how I would do. If you have something different that is better than this, let me know. Okay. So this is this matrix 3 cross 4. What are the dimensions of my x vector? 4 cross 1. So this is what 4 cross 1. This matrix multiplication will give me a output of size 3 cross 1, right? 3 cross 4 cross 4 cross 1, that is going to give me a vector of 3 cross 1. Now tell me, what is the first element? So this was W1. Now let me write, if I write it here I will have issues, but let us do this. So output will be, I am not going to write the whole thing like I wrote here. It is W11 x1, W12 x2, W13 x3, W14 x4. I am still missing something, plus there is a vector of, what will be the size of B1, B square brackets में 1, 3 cross 1, because there are, you have to follow this whole lecture. इसमें कम से कम 2 नंबर छिपे हैं मिड टर्म 1 में. Okay? क्या बोल रहे हो? All right. So this is what you have. Now W11, by everybody knows how to multiply matrices. So this whole thing gets multiplied with this whole column element wise. You add them and then you add bias. I am not doing that here, or let me do that for the sake of completeness. So plus B1, B2, B3, B4, right? B3, okay. B3. Now, what will be the output? 70% of your bugs will be ruled out. You won't have them if you know the dimensions of your matrix and if you know how your code is playing with them. 75% of the errors are related to just the dimensions of the code, I mean the matrices in your parameter matrices in your code. So, this one gets multiplied with this one, I add B1, which calculation is this? This is for which element, this calculation? Z1. So, this one is precisely Z1. What about this one? So, for next element, this row gets multiplied with this column plus B2, that gives you Z2. This is what I had asked you to compute. And then finally, you have Z3. Any questions here? Even if a single student asks me to repeat anything here, I will do that 10 times. But you have to ask me. Yes? Anyone here? What we are doing is 11th class matrices. Okay? Questions here? Now, I should have written actually 1 here, 1 here. Why am I not doing it? I am calling it W1, I am calling it X, I am calling this vector as B1 and this vector as Z1. Even a single doubt, however silly you might think it is, still ask. You have to be crystal clear with this. Unless your answers are crystal clear in your midterm copy, no marks. Is this equation fine? This was for the computation of Z1. Okay. Now, so we have computed Z1. Z1 for this complete layer. Okay. Now, how will you compute A1? A1 will simply be sigmoid of Z. So, basically element wise take sigmoid. Okay. You know, board should have looked better. ये काम बीच में ये आ रहा है और Thank you. इतने गौर से देखने वाले हो तुम्हें? Okay? हाँ? बोलो. Right, right. क्या करूं बताओ? See, that's where this convention kicks in. Now, if you have linear regression, so I'll use this anyway. If you have this, weight vector would look like W1, W2. But if you use this convention, your weight matrix will look like 1 cross N. So, this convention of choosing this cross this takes care of the transpose. Okay? Done? नहीं, this convention is there to take care of the fact that you won't have to take transpose, right. So, as I said, W1 could have two dimensions, this cross this or this cross this, that basically means either W or W transpose. So, you are already choosing W transpose. So, you are calling W transpose as W. All right. Now, this was just the computation of Z1. I want you to give me A1 as well. And all this that we are doing it for one example only, okay, for one training example. How will you compute A1? So, A1 is nothing but sigmoid of Z1. What will be the dimensions of A1? A1, A2, A3, it will be a 3 cross 1 vector. Compute Y hat similarly. Yes. Compute Y hat. Not Y hat, compute Z2 first. So, Z2. I am okay if you write equations right now, but I will very much prefer vectorized form. Done? Have a look at this particular figure and it should be so what will be the equation now? So this is W2. This is W2. What are the dimensions of W2? 1 cross 3. So this is W2. Now this gets multiplied with A1, right? Of course, A1, very good. Plus B2. What is B2? 1 cross 1? All right. So W2 will have 3 weights, W1, W2, W3. Okay. Now when you say W2 and our convention is later cross previous. So 1 cross 3, this is 1 cross 3, this is 3 cross 1, they multiply to give you 1 cross 1 plus 1. Now what are the exact calculations happening here? W1 cross A1 plus W2 cross A2 plus W3 cross A3 plus bias. This is same as you are doing on every neuron. If you see, every neuron is a logistic regression unit. Okay. What will be Y hat? Sigmoid of Z2, and that is your final prediction. So can you do it for this particular neural network now? Give me the total number of parameters and all the equations. So quickly, give me the dimensions of W1. This is how I want you to write it in exam. W1 is equal to 5 cross 10. Now is this over for first layer? No. You have to give me B1 equal to 5 cross 1. Okay. Even if you don't add this finally, I am okay with that. But every matrix, every bias should be correct. Right. So it's okay if you don't add them in the last. Now tell me W2. So W2 is here. It is 3 cross 5. Anybody who is not getting this, let me know. 3 cross 1. W3 is, so this is my W2, this is my W3 and this is my W4. So W3 is 2 cross 3 and B3 is, and finally I have W4 1 cross 2, B4 is equal to 1 cross 1. Okay. How many parameters in total? Just sum kar do. Okay. Whatever it is I said ki I just don't care. As long as these matrices and biases are correct, I don't care ki whether you sum them or not. Now, what will be the equations? Since there are so many and मेरा कुछ नहीं जा रहा, मैं तो यहाँ पे 10 layer बना देता, right? You wouldn't keep on repeating things 10 times. So you have to give me a general equation now. So you have to give me this. First layer, first matrix, first layer, first matrix, first layer. What will here I have? Wi, Ai minus 1 plus Bi. And what will be Ai? Sigmoid of Zi. And you don't have to write it for all of them now. Now this happens for all I 1, 2, 3, 4. I could have been more formal, but ठीक है. Okay. For all I in now you can find the other way around as well. Some people will write Wi plus 1 Ai plus B, I plus 1 is going to give you Zi plus 1, and then you again take sigmoid to get Ai plus 1. Now we will have problem here. I said I goes from 1 to 4. What happens at I equal to 1? A0? What is A0? A0 is X. Okay. So A0 is X. Any questions here? बताओ कहाँ लगाना है समेशन? Zi equal to summation of this. What are the dimensions of this? It's a matrix, it's a vector. So this matrix multiplication is taking care of all those summations that were required. All this computation is done for one training example. Let's say you have 10,000 training examples. First example comes, go through this, gives you y hat. Second example comes, go through this, gives you y hat. And this happens how many times? 10,000 times. Okay? We'll come to this in the next class, but just letting you know, if you have 10,000 examples, each one of them is supposed to pass through this. Each one of them is supposed to give you a y hat I that will dictate your cost function, and finally you will update. So when will you update according to our gradient descent algorithm? Remember how was J computed? J was, in either case J was, we were summing J for I equal to 1 to M, that means complete data set. Now this was okay in old days of machine learning when you had 1000 examples, 2000 examples were considered good. In today's world, billions might be less. So let's say if you run billions of examples through this and you figure out ki in my update equation I had accidentally pressed instead of 0.1, 1. You will realize after maybe 3 days that you had made this mistake, right? So these days you use something called stochastic gradient descent. We'll come to that later, but in fact flush this whole thing. If you have m examples, each one of it will pass through this and you will compute y hat for each one of them. Okay? Now, so you understand everything that is here. Now, data set, this one, is this linearly separable or not? This is linearly separable. What does it mean? There exists a straight line that will classify or separate this data. Okay? Now, if you see here on this side, you have these 7 features, x1, x2, x1 square, x2 square, x1 into x2, sine of x1, sine of x2. Okay? You also have activation, you can use 10H, ReLU, sigmoid. So, which one do I go for? Sigmoid, chalo, sigmoid, tumhari ichha. Now, epochs will be here. Ratio of training to test data, 50% of it is training and 50% of it is test. Noise is 0, batch size is 10. Okay? So, we will make sense of this a bit later. Learning rate is 0.03, this is standard. So, do not change this unless you have good reasons to do so. Regularization, for the time being none. Regularization rate 0, and problem type is classification. We are not doing linear regression here. Shall I run? All right. So you see, this is the most important curve as we talked about, right? Let me okay, I am redoing this. So look at the test loss, look at the training loss, and you see in less than 35 epochs the graph looks like this. This is what we were looking for. Okay, we already see a classifier here, right? So this is pretty good. You just have 2 features x1, x2, and you are able to classify this data set. Easy one. If so test loss is 0.001 already, training loss is 0.002 already, maybe I can run this a bit more. Okay, you run it long enough, you will get 0. It was possible to get 0 in this case. Why? Because there exists a line that will separate both these classes 100%. Okay. Now, help me with this. I have features x1, x2, what do I do? What do I do क्या? ये चलाया and it does not work because is this linearly separable? There does not exist any line in this world that will separate it, I mean completely, right? So you will see things like 50% of it, no matter which line you choose, 50% of error it will do at least, okay? So what does this mean? What does this mean? जल्दी बताओ. What do you think will separate this data? I don't know what are hidden layers. Yes. Feature बढ़ा दूँ? All right. All right. So it does not work. ये लो. हाँ? What does it mean? You have to have the right features. Okay. Now, why x1, x2? What is the equation of a hyperbola? What is rectangular hyperbola? Chalo, we'll continue from this in the next class.